Hello everybody, my name is Stephen Kwan. Today I'd like to spend a few minutes talking to you about our Predictive Emissions Monitoring System, or PEMS, which is an extension of our Bentley Performance online performance monitoring software solution. First, a quick overview of PEMS. PEMS is a technique for modeling and predicting gas turbine emission constituents such as CO, NOx, CO2, and unburned hydrocarbon. A PEMS solution provides an assessment of gas turbine emissions without using a continuous emissions monitoring system, or SEMS. Our solution today supports two categories of gas turbine types, and they are the GE-LM 2500 and the GE-LM 6000, and we support all variants of these two gas turbine types. We do support other gas turbine types, but other gas turbine types will require additional engineering assessment, primarily in order for us to evaluate whether sufficient manufacturer's design data is available. As mentioned earlier, our PEMS solution is an extension to Bentley Performance, which is part of our System 1 condition monitoring software platform. The overall concept of our PEMS solution is that by leveraging Bentley Performance, we're able to provide the actual and expected gas turbine performance. With this information, we're able to establish a base gas turbine performance versus emissions model. And after the PEMS solutions deploy, we provide the capability for the user to update the models with actual portable SEMS measurements. By doing so, we are able to calibrate and tune the PEMS model using SEMS data in a periodic fashion. For our standard gas turbine types, we require 2 SEMS tests every year to tune and calibrate the PEMS software. And for non-standard PEMS gas turbine types, we require 4 of these SEMS tests during the first year, and then 2 SEMS tests every year thereafter. For our standard gas turbine type, we start with the GE's proprietary apps software module, which provides a correlation between gas turbine performance and emissions for NOx and CO. The app software allows us to produce models that are sensitive to the load or the power that's being produced by the gas turbine, the ambient conditions, the fuel composition, and we're also able to handle gas turbines that are configurable for 2 different fuel types. And our PEMS solution, again, allows us to tune and calibrate these models using portable SEMS measurements. CO2 and unburned hydrocarbons are parameters that are calculated based on mass and energy balance of the gas turbine and also the underlying physical models. Our PEMS solution was introduced at the fall of 2008, and we have been running a trial site at a platform in the North Sea, which consists of 3 GE-LM 2500 plus SAC gas turbines. Here's an example of the display screen within System 1 for one of these gas turbines on this trial site. Many of the parameters has been blanked out due to its sensitive nature, but on the right-hand quadrant of this display screen, as you can see, our PEMS solution provides information to the user in terms of the actual PEMS prediction versus the expected emissions constituents based on the manufacturer's design data. Here's an example of the type of accuracy level that we expect out of our PEMS solution. You can see the blue trace is the actual SEMS measurement. The pink trace is the result from our generalized model prior to the initial tuning and calibration. As you can see, our base model is fairly accurate to begin with, even before the initial tuning and calibration. And after the initial tuning and calibration, the results that we saw at this particular trial can be seen on the yellow trace. As you can see, it very, very closely follows the actual SEMS measurement for this particular gas turbine. For additional information, please contact myself, Stephen Kwan, at Stephen, S-T-E-T-H-E-N, Kwan, K-W-A-N, @ge.com, and I can be reached at area code 775-215-1871.